Hi everyone, my name is Andrei and I'm doing different iOS-ish things at Peso. And initially I planned to give a presentation about Xcode Playground, but then we changed the topic, but I didn't change completely my mind about the playgrounds. So today, the entire presentation, including the slides, are in playgrounds. Okay, and the topic is abstract relationships in Swift. Alex told me that the title is pretty abstract. That was intentionally. Okay, so actually we'll talk about types, and more specifically about concrete types and abstract types and the relationship between these. Okay, so let's start with what types are. A concrete type is probably it's a type that you met so many times, like int, string. Let's say if we have a variable, we can create an int, a string, an array, anything that compiler can understand what's that. So basically, if you can initialize that type, you can run init on that, then it's a concrete type. Okay. An abstract type, though, is something that compiler has no idea about. And in Swift, there are two ways to define abstract types. So first one is as a part of generics. So let's say if we have a struct called box, and it's generic on some type called wrapped. So this wrapped thing is an abstract type. And compiler doesn't know what this means in this context, but then when you want to use the box, like when you want to initialize that, okay, not that, yeah, emotions. Then you have to replace the wrapped thing with something concrete, either implicitly, like here you put a string, or explicitly, defining in square brackets string. Okay, so this is first way you can make the abstract types. The second way is using associated types in protocols. So let's say we have a protocol called conference, and we have an associated type called location. So location is the abstract type here. And if we have any type that conforms to protocol conference, then at some point in code, that type has to replace location with a concrete type. Okay, this was theoretical part, so let's jump into some real use case. And when I think about types in Swift, and more specifically about abstract types, I cannot find another example, or I cannot compare as complexity with anything than relationships between people, and more specifically, relationships between boys and girls. So we'll take a use case, pretty nice one. So we have three boys. We have John, which is a smart guy. We have Tom, which is a pretty guy. He's nice looking. And we have Matt, which is a perfect. He has both. He's smart and nice looking. And we also have two girls. Emma is a smart girl, and because of that, she loves smart guys. And Kate, she's a pretty girl, and that's why she loves pretty guys. And our job here will be to put them together, to match them. We'll act like some sort of Cupidon. Okay, and let's go to live coding. We'll start with some simple implementation using structs, and then we'll continue with a little bit protocol-oriented thingy, and we'll end up with abstract types and a little bit of more advanced stuff. Okay, so let's start with structs. We'll have a struct for boy, and the boy will have to impress somehow. Okay. No, it's not this one. I created snippets in order to help me, but it doesn't seem like it's the case. Okay, and we have another struct for girl. Yay. Girl. And the girl will have a function. She will have to date a guy. So, they, partner, and that will be a boy. All right. Okay, and let's create I'll move this up. So, can anybody see what I type here? Is not too small or something? It's cool? Okay, good. Let's create our boys. Okay, so we have John, which is a boy for now. We'll have Tom, our pretty guy, and we have Matt, the perfect one. Okay, and let's create the girls quickly. Hey, girls, let Emma be a girl. Yeah, I'm scared. And let Kate be a girl. Okay, and now that we have boys and girls, let's create the relationships. And now Emma can date with John, because John is the smart guy, and Emma loves smart guys. And Kate can date Tom. Okay, so far we have a pretty simple implementation, and it works, except that it doesn't work very well, because Kate can also date John, and that's not the case. Kate loves pretty guys, but John, unfortunately, is just smart. So we'll have to do something. And in order to solve this, we'll have to create different kind of boys, right? And let's keep simple and just duplicate, to copy-paste this one here, okay? And we'll make our boy smart. And let's tell that he will tell smart things, and this is a smart thing that a boy can tell, and he will impress by telling these smart things. Okay, our second boy is a pretty boy, and he will impress by smiling, because he is pretty, he doesn't need to do anything special. Okay, and the third one is our perfect boy. Let's just copy and this. Actually, copy and paste always work. It's a pretty powerful technique, so I recommend you to use. Yeah, let's copy this, put here, again copy and paste, and this will be our perfect boy. And if he will smile and that doesn't work, then he will start telling smart things. That should work for sure. Okay, so let's transform our boys into what we have now. Pretty, and this will be the perfect boy. Okay, so we did this. We have 3 different kind of boys, but our girl doesn't know what boy means in now. And that's because we have 3 different structs, and they don't share anything in common. And we also ended up with a lot of duplicated code, as you seen. And you probably feel that something wrong, that this is not the way we should do. And now we can solve this with classes and subclasses like we do in any OOP language. But in Swift, we want to do somehow else. We have structs which are value types, and we want to keep those. So let's use instead protocols. Yay, protocols. Okay, so we'll have a protocol for boy. Okay, and he will define the function impress, because that's what every boy does. And I hope we'll have a protocol for smart, and this one tells smart things. And we'll have a protocol for pretty. And this one just smile, because he smiles nicely. And he's a nice boy. Okay, and now that we have these protocols, we can tell that our smart boy is actually a boy that's smart, right? Our pretty boy will be a boy that's pretty. Yeah, and our perfect boy, it's a boy that has both smart and pretty. Okay, and one nice feature that protocols have in Swift is default implementation. So we can extend our we can make protocol extensions, and we extend our protocols, and we can define a function. Let's do that for smart extension, smart, and we'll tell that as a default implementation for function tell smart things will be our print. Okay, so this means that any type that conforms to protocol smart will get this implementation for free. Let's do the same thing for our pretty. Okay, and we'll copy from here. Copy and paste. Don't forget to copy and paste. And now that we've done that, we can remove all the duplicated code. OK, that's nice. We ended up with a structure built with protocols. And now our girl knows what boy means because we have the protocol boy. And OK, everything is fine, except that we didn't actually solve the problem because Kate can still date John. And yeah, that's because we have two kind of girls, but here we define just one struct. So let's do the same thing for a girl. Let's tell that we have a smart girl, and we'll copy and paste again. Okay, someone will say that the entire presentation, this guy just copied and pasted. Okay, pretty girl. And because we have two girls, we can do the same trick like we did with boys. We can create a protocol here for girl, and this one will define the function date. Okay, here. Okay, and now our smart girl can say that she wants to date just with smart guys. So let's put this here, and our pretty girl with pretty guys. Okay. Now we should get an error, actually, but because of the playgrounds running working area, we don't get that. Wow. Oh, yeah, I forgot to conform our girls to the protocol. So this one conforms to protocol girl, just one space, and this one also conforms to protocol girl. Yeah, and we had this compile error, and that's because we defined our function. So we told that our function will get a boy, but here we get a smart boy, and it would be nice to have something in our protocol that it's more relaxed. Like it allows us to take anything in our smart girl and pretty girl, and that's where associated types comes. So let's create an associated type and call it partner. Okay. Partner. And instead of boy, we'll have a partner. And now any struct that conforms to this protocol will decide for itself what partner means. And smart girl tells that instead of partner, we have a smart boy. And pretty girl says that instead of partner, we have a pretty boy. And yeah, let's convert this to our types. And now Kate cannot date John, which is a correct thing. But let's try to see if Kate can date Matt, because Matt is our perfect boy. If you forgot, then I'll put this here. So this is our perfect guy, and Kate should be able to date with Matt, because it would be a pity for a perfect boy not to be able to date with someone. So that's not good. Let's make some changes in order to be able our girls to date with Matt. And the way we can do this, now that we have protocols, instead of telling that we'll take structs for smart boy and for pretty boy, we can use protocol composition and tell that, OK, we'll tell anything that conforms to both smart and boy. So let's do that. Anything that's smart and boy. Actually, it's better otherwise. It's a boy and smart. And here we can say that, OK, we have a boy that's pretty. It doesn't tend just is easier to read boy and smart. OK. So that's it. Yeah, Kate can date Matt, and Emma should also be able to date with Matt. OK, cool. So we did it. Let's recap a little bit what we've done. So we created a bunch of protocols that allowed us to build the structure for boys. And we use an associated type to relax our protocol and to allow to put instead of partner anything we need. And yeah, after that we use protocol composition to be able to give to a parameter something that conforms to two protocols. OK, and that's cool. And from now forward, a little bit of advanced stuff is coming. So I will recommend you to fasten your seatbelt and be prepared. And because I don't have a seatbelt, I will put my hat with Amsterdam. OK, just to be sure. So, OK, ready? Go. So let's say everything is good. time passes and our boys decided that they want to marry. And in order to marry, they'll have to propose, right? So let's define the propose function. Okay, propose, and of course they have to propose with ring. And because we don't know what, do you hear me? Because we don't know what ring means in this context, let's create another associated type, and we'll call it ring type. Okay.
Propose with car?
I don't know. We can try it after that. So yeah, let's propose with a ring for now, and if that doesn't work, then we'll try with the car. Okay, so the boy will propose with the ring, and let's quickly create an extension and define a default implementation. Extension boy, and I will copy this from here and put here. Let's see if I have a T conference box. Okay, I don't have. So let's print it. And as usually, will you marry me? Yay. Okay. One more thing that we have to do is, because we have this associated type, our boys have to replace the associated type, the abstract type, with something concrete. So we'll have to replace with something, but we don't have a ring now. So let's create a ring quickly. Okay. Struct. Okay, we have a ring, and we'll tell that ring type is actually a ring. Okay, it's a ring. And we'll do this for every boy. Okay. So we figure out with the boys. Let's see what girls say. And it says something weird. It says that protocol boy can only be used as a generic constraint because it has self or associated constraints. And probably this is the weirdest thing that you can met when you try to use protocols a little bit more in Swift. And this is actually a Swift limitation. And what Swift compiler wants to say here is that because we have associated type in protocol boy, and this is an abstract type, Swift doesn't know what ring type means in this context, like where the here. So for the compiler, ring type is something abstract, but Swift is strongly typed, and it has to know at compile type everything, like any type for any variable, parameter, or return type. Okay, so one thing we can do here is to listen to compiler and use these protocols as a generic constraint. So we can make this function generic and say that, okay, we'll have something, a b, which will conform to both boy and smart. Okay, and here we'll use our b. And we can, okay, let's wait for, okay. And now, because our girl also has an associated type, an abstract type, in this context, smart girl doesn't know what partner means. So we cannot make just our function generic. We have to make our entire struct generic. So instead of having a generic function, we'll have a generic type. Okay, and now we can say the partner is that b. We have to do the same thing for our pretty girl. Okay, so pretty girl will be generic on some pretty boy. And here's our b. Okay, and because we created generic types, we'll have to instantiate with some generic type. So we'll say that smart girl is generic on smart boy, and pretty girl is generic on pretty boys. Okay, let's see what happens. Now that we made our struct generic, we have a little bit of a problem. Emma cannot date Matt anymore, and Kate cannot date Matt as well. And that's because we made both girls, we made Emma generic on smart boys, and Kate we made generic on pretty boy. And that means that if Emma is generic on smart boy, she can only date with smart boys. We can change that. We can say, okay, she can date with perfect boys, but then she won't be able to date with John, which is the smart boy. Okay, so this is a good thing for some cases, like for arrays or dictionaries. But in our case, we need something else. We need some more dynamism. And to do that, we'll have to make a hack, actually. So here is where type erasure comes. Type erasure. So, okay, this is for you. Type erasure. So what type erasure means in Swift is making something abstract, transforming something abstract into a concrete type. Okay, so the way we do that, we create a concrete type that will conform to boy and smart, then inject some abstract type into that concrete type. We store the function from the erasing from the object that we injected, and then we'll reject the function. So that's a little bit advanced. But let me explain you how this works. So let's say we have a function. And remember, the functions are first-class citizens in Swift. So that means that we can have a variable. And if that's type of a function, if it's something that takes a string and returns nothing, then we can assign to our variable this function, say hello. And later on, we can call our function with a parameter, a quad way, and the implementation from this function, from initial function, will be called, I hope. So this is actually one of the reasons I didn't make the talk about playgrounds, because playgrounds sometimes doesn't work as I would want to. Okay. What you want to do here is to see hello codeway. It should work. It doesn't for now. Let's try to rerun. I'll make the trick. I'll close everything. Okay. Those were my previous tries to make the presentation. Okay. What now? Okay. Hello codeway. So what we done, we have a variable, and we stored this implementation into this variable, and then we called that, and the implementation from here was executed. Okay. So this is the same thing we'll do in our type erasure. So let's do it. Let's create a struct, because we said that we need a concrete type, and we'll call that any smart boy. And this has to conform to these protocols, to boy and smart. Okay. Let's move this a little bit up. And we'll have the two private methods for two private properties for storing our functions. Private let, and we'll have the function for impress that takes nothing and returns nothing. Okay, private let proposed that takes a ring type. What's that? Oh, okay. That takes a ring type and returns nothing, because that's the types that we have in our functions. And now we'll have to inject, and we'll inject using our constructor. So we'll have something that can be initialized with an abstract type that conforms to both protocols boy and smart. And here will be our erased B. Okay. What do we have here? So yeah, compiler says that it doesn't know what ring type means. So that's why we have to make our struct generic on something that will replace ring type. So we'll say, okay, we'll have something, for now is R, and here will be our R. Ring type R. Okay. And yeah, and let's store the function from erased into these properties. So we'll have impress, we'll take the function from erased. Okay, and for propose, we'll take from erased as well. Okay, and now Swift should tell us, but yeah, it doesn't know if what ring type from B means, and we'll tell that, okay, we have the same ring type, so B ring, okay, B ring type is the same as our R. It's as our ring. Okay, are you still here with me? Okay, now the easy part comes when impress is called, then we'll execute the functions that we stored in our properties, and if propose is called, then we'll call propose with the ring that we get as parameter. Okay, so this is actually it. This is the type erasure. It's a little bit advanced and a little bit complicated at the beginning, but if you do it a couple of times, then it seems easy as anything that you do multiple times. Okay, so instead of having the generic thing here, we can say that, okay, we don't need this anymore, and we'll just have, so our smart girl will date with any smart boy that has a ring, because the ring is important here, right? Or a car, it depends. But now we have a ring. And let's see what happened to Emma. Yeah, Emma is not generic anymore, and yeah, now she should be able to date to date with both John and Matt, but we have to inject in our erased thingy. So we'll create any smart boy, and we'll insert there John, and we'll do the same thing for any smart boy. Okay, with Matt, and we can do the same thing for where is that? For boy and pretty, but we won't do for now. Okay, so here is all the live coding. Let's go back to our presentation and recap a little bit. So what we did, we used protocols to give some flexibility to our design, to be able to use default implementation, to be able to use protocol composition. We also use generics and associated types to give more dynamism in our code, to be able to use something abstract and that can be changed after that. And remember that once you have protocols with associated types, then most probably you'll meet this problem that says that protocol X can only be used as a generic constraint because it has self or associated type requirements. So the only way we can bypass this limitation is to use type erasure for now. Hopefully, in the next version of Swift, this will be fixed by Swift team. But for now, we just have to do it. Either we use classes and subclasses, or we have to deal with that. Okay. Here we have a couple of resources. If you want to read more about associated types, Ross Bishop has 3 blog posts very interesting about why do we have associated types in Swift at all, and about type erasure. Hector Matos has a video that he gave at AltConf. He gave a presentation there, and it's very nice. He explained very simple how to do type erasure. So I recommend you to watch this. I'll put how is that called? Okay, the playground I'll put in GitHub, so you will be able to see this. Yeah, and now that we have our boys and girls happy, thank you. And here are my contacts. Yeah, if you want to see what I do on GitHub, you can use that nickname. I do something sometimes. Okay.